Welcome to Interface Studies. My name is Saleh. In the age of artificial intelligence and generative everything, an old yet overlooked idea is quietly returning: the Zoomable User Interface, or ZUI. The ZUI is the notion of an infinite continuous canvas, a space where information isn't confined to pages or windows, but can be freely arranged, explored, and created. It represents a very different cognitive model of interaction, one that treats digital space as a living environment rather than a sequence of screens. The idea itself is as old as modern computing. It has re-emerged many times across decades of research, each time promising to liberate users from the rigid metaphors of the desktop. Beneath its visual novelty lies a profound question about how humans think and remember. At its core, a ZUI allows seamless navigation across scales. You zoom in to reveal details, text, images, data in general. You zoom out to view the larger structure. The power of this approach lies in its harmony with spatial memory, our natural ability to recall locations and distances. When we search for our keys, for example, we don't think of categories or file names. We remember places: the desk, the counter, or the table. Traditional interfaces built on the WIMP model, the Windows, icons, menus, and pointers model, rely instead on symbolic memory. They ask us to recall names, hierarchies, paths. The ZUI bypasses that symbolic burden, replacing it with something more instinctive, moving through information as though it were a physical space. This spatial logic is why researchers have never let the idea die. It feels intuitively right, an interface aligned with the way human cognition already works. Yet, as history shows, the gap between feeling natural and working effectively has always been immense. The story begins in 1963 with Sutherland's Sketchpad, often hailed as the first computer graphics program. While its technical achievements were extraordinary, its deeper innovation was the interaction model. Using a light pen, users could draw directly on the screen, manipulate shapes, most importantly, zoom in and out without losing resolution. Now, because Sketchpad was vector-based, details scaled infinitely. This simple act of continuous zooming revealed something revolutionary. The computer screen didn't have to mimic the fixed frame of a printed page. It could be a navigable world. Sutherland also introduced ideas that remain foundational to interactive computing today. One of them is constraints, rules defining relationships between objects. He also introduced object hierarchies, structures of reusable components. A circle could remain bound to a line. A master shape could spawn variants, and entire structures could respond dynamically to a single change. Digital space, in Sketchpad, became a dynamic information structure, a navigable living system rather than a static image. A decade later, these ideas resurfaced at the MIT Architecture Machine Group, precursor to the MIT Media Lab. Their project, Spatial Dataland, envisioned an infinite plane populated by digital artifacts, documents, videos, images, all of them arranged freely across a navigable field. Users could pan endlessly, zoom into clusters, and interact with media directly. To navigate this environment, the team experimented with hand tracking and voice control, decades before such technologies became mainstream. Their goal wasn't just technical, it was philosophical in a way. They sought to restore the body's natural relationship to space within digital environments. For them, this infinite canvas, which is a term that never materialized until the year 2000, was never merely a way to scale graphics. It was a way to free thought from the file and the menu. A way to move, think and associate visually, physically, and semantically. At the time where the MIT researchers were experimenting with the navigable digital space, another group on the opposite coast was shaping the very foundations of modern computing. Xerox PARC. At PARC, researchers were working on Smalltalk, which is a programming environment embedded on an operating system level, along with its graphical user interface. The creators of Smalltalk were aware of its limitations. They imagined something far broader than what appeared on the surface of Smalltalk. It was more of an infinite workspace, where projects and objects coexisted continuously rather than being trapped within isolated applications. But when Apple adapted Park's ideas into the Lisa and later the Macintosh, much of the original fluidity was lost. The commercial GUI that was shipped with these systems froze the metaphor into fixed windows and discrete apps. The concept of the computer as a continuous spatial medium, what Park researchers saw as well, was reduced to a predictable set of boxes on a desktop. By the mid-1970s, the conceptual seeds of the XUI had already been planted: continuous zooming, spatial organization, and context at multiple scales. But the technology to realize it was still decades away. The computing power needed to render hundreds of scalable objects smoothly. Early machines lacked the memory, the processors, and display resolution required to make infinite navigation viable. But the WIMP interface, by contrast, offered something computers of that era desperately needed: predictability and containment. It divided complexity into manageable units. Each window was a controlled process, independent and limited. Most importantly, it worked commercially, and people trained on it, and it worked cognitively. It gave users anchors and boundaries. For the personal computers of the 1980s, that constraint was a feature, not a flaw. The XUI vision re-emerged only in the 1990s, when hardware finally caught up. The revival began at New York University's Media Research Lab, when Ken Perlin and David Fox introduced a prototype called PAD in 1993. PAD was conceived explicitly as an alternative to conventional interfaces, a working model of an infinite two-dimensional plane with no edges or borders. Every digital object existed somewhere on this plane, at a fixed coordinate. Users could scroll or zoom to any point, navigating through documents and media as though traversing a vast map. The project also introduced a key innovation: the portal, which is a movable, resizable lens that could display a different region or scale of the same infinite space. This gave users multiple simultaneous views, allowing them to interact with distant areas of the canvas without losing orientation. The potential was unmistakable, and it inspired the next leap.
Imagine a world without windowing systems. What other interface strategies would we be using instead? Our research groups at the University of New Mexico and New York University have been looking at alternatives to the windows, icons, menus, and pointer, or WIMP interface metaphor that has become so prevalent. We have been exploring a novel user interface paradigm based on zooming. The interface metaphor we present is that of a huge planar information surface where documents can be placed not only at any position, but also scale to any size.
PAD++, developed by Ben Peterson and Jim Holland. PAD++ refined Perlin's idea by introducing animated continuous zooming. Instead of jumping abruptly between scales, it interpolated movement smoothly, making transitions feel natural and embodied. Objects didn't pop in and out. They flowed and grew, creating this visceral sense of flying through information space. This small change solved a major perceptual problem. Users could now maintain orientation because their movement had continuity. They always knew where they came from and where they were going. The animation preserved context, which became the defining trait of a true Zooey. For a brief moment, researchers believed the Zooey could replace the desktop metaphor entirely. Toolkits like Jazz, Piccolo, and Piccolo 2D emerged to help developers build applications on this new model. The term, Zoomable User Interface itself, was formalized in 1997, coined by Franklin Schreiber and Tom Gruber at Sony Research Labs. They were working in collaboration with the NYU and Maryland teams. While this research flourished in academia, a parallel thread emerged from a very different temperament. Jeff Raskin, the original designer of the Macintosh. Raskin had grown disillusioned with the GUI clutter and inconsistency. He argued that the desktop metaphor forced users to manage computers rather than simply use them. But his late project, Archie, sometimes called the Humane Interface project, imagined a purely keyboard-driven zooming world. Every task, file, and document existed within a continuous plane, navigable through simple keystrokes. There were no windows or icons, only scale and position. Raskin believed that such a model could remove the need for constant task switching and window management. Though the system was never completed, his advocacy preserved the Zooey as a philosophical countervision to mainstream computing, a vision of computing as a coherent, spatial experience rather than a stack of boxes. Now, by the mid-2000s, elements of the Zoomable interface quietly began filtering into consumer technology. These fragments appeared in specific contexts, places where zooming felt natural rather than experimental. One of the earliest commercial examples came from Hillcrest Labs in 2006. They developed a zoomable navigation system for television set-top boxes. Instead of digging through multi-layered menus, users could navigate a single continuous structure using only a remote control. The concept was simple and elegant, but again, the market wasn't ready for it. Limited hardware power, the dominance of traditional menu design, prevented it from taking off. It hinted, though, how spatial navigation could simplify complex interfaces.
Right? So I can even
The
swipe
true
when I'm in a
cultural
landscape here.
turning point came just a year later,
Isn't this
in
awesome?
2007, when Apple introduced the iPhone.
I can take any of these pictures and I can make them bigger. I can bring them closer together or move them further apart to make it bigger or smaller. And so I can just move them further apart and stretch the image.
With it came a technology that would reshape our collective sense of digital space: multitouch. For the first time ever, millions experienced the now iconic pinch-to-zoom gesture in maps, photos, and web pages. What had been a research concept since the 60s suddenly became an everyday reflex. Naturally, using hands. The fluid animation, responsive rubber band effect at screen edges, and near-perfect performance made zooming feel physical, almost tactile. However, it was important to note that the iPhone popularized only bounded zooming. The gesture entered mainstream consciousness, though, but the philosophy behind Zooeys, the notion of unified, continuous, endless space, remained absent. Apple taught the world how to zoom, but not where to go. Another company tried to revive the Zooey ideal more explicitly. It was in presentations. Prezi reimagined the presentation format by ignoring PowerPoint's linear sequence of slides and replacing it with a boundless canvas. Presenters could place text, images, and video anywhere. Then define a path of pans and zooms to guide the audience through the narrative. It was dynamic and cinematic, evoking flight through an information landscape. Both PowerPoint and many other applications still with us today, including Prezi. It didn't take over traditional presentations, but it was an interesting concept. But it also showed something interesting. The freedom of navigation came with a price. Without strong structural discipline, Prezi presentations often disoriented audiences. The very motion that made them visually striking also made them cognitively exhausting. Some researchers pointed out that while spatial navigation can enhance comprehension, excessive movement and lack of anchors do the opposite. Prezi succeeded in demonstrating both the potential and the pitfalls of spatial storytelling. It showed that a Zooey could make ideas come alive, but only when anchored by thoughtful hierarchy and restraint. Around the same period, Microsoft was quietly exploring another dimension of the Zooey concept, one rooted in physical collaboration rather than individual navigation. In 2008, they launched Microsoft Surface, later renamed to Pixel Sense. Unlike the tablet that would adopt its name years later, this Surface was a table, a large horizontal interactive display resembling a piece of furniture. Pixel Sense detected multiple touchpoints and even recognized physical objects placed on its surface. Several people could gather around it, zooming, panning, and rotating digital artifacts simultaneously. It embodied a social vision of computing, the digital workspace as a shared physical space. Now, while the product was expensive and ultimately confined to commercial settings, its conceptual influence was profound. It demonstrated how a zoomable interface could serve not just individual cognition, but group collaboration, restoring some of the embodied, tangible quality that the MIT Architecture Machine Group had pursued decades earlier. By the early 2010s, multi-touch became universal. Pinch-to-zoom gestures were embodied in phones, tablets, and trackpads. On a MacBook, for instance, the two-finger pan or pinch-to-zoom felt second nature. Yet, despite the ubiquity of these gestures, the larger dream of a system-wide zoomable user interface remained elusive. Zooming had become a feature rather than a framework. It existed within apps, not as the structure uniting them. Zooey principles found a fertile ground in domains where scale was not a luxury, but a necessity. The most successful and perhaps unnoticed implementation was mapping. Applications like Google Earth and Google Maps embodied the zoomable philosophy perfectly. Users could transition seamlessly from a planetary view down to a single street. This wasn't simply a technical triumph for rendering, it was a triumph of semantic zoom. Semantic zoom means that the meaning of information changes with scale. At the global level, New York City appears as a label or as a dot. Zoom closer and road networks emerge. Zoom further and buildings, street names, and landmarks appear. The interface dynamically adjusts content to the appropriate level of abstraction, preventing visual overload. This approach solved one of the earliest problems in Zooey research: orientation. Infinite digital space, by contrast, risks this disorientation. Semantic zoom reintroduced hierarchy through context. It made infinite space intelligible by letting scale itself define relevance. Not every experiment succeeded, though. Take PhotoMesa, for example, an early 2000s photo browser built around zoomable navigation. It let users explore thousands of images on a single canvas, grouping and zooming freely. Technically, it was elegant, but practically, it failed. Some users struggled to locate specific images within such an unbounded field, often reverting to conventional file browsers that offered simple lists and search. The lesson was clear: existing conventions are extremely powerful. By the early 2010s, researchers and designers had reached a shared understanding. Zoomable interfaces thrive when constrained and purposeful, when scale is essential to the task, as in mapping, or when motion follows a disciplined narrative, as in structured presentations. Outside those contexts, infinite canvases quickly become overwhelming. The idea had matured, but was still waiting for a new context, one that could make spatial navigation both intuitive and necessary. The most successful and lasting revival of the Zoomable interface began in the 2010s. Not in academia, but in the design and collaboration industries. This time it wasn't theoretical, it was practical. Platforms such as Miro, which was called Real-Time Board, or Figma, reintroduced the infinite canvas as the default workspace. In these environments, users could pan and zoom effortlessly across a shared board that extended in every direction. Dozens of collaborators could work simultaneously without performance issues, something that would have been impossible a decade earlier. The breakthrough came partially from technological maturity, with the rise of WebGL and modern browsers that could finally render complex, scalable graphics smoothly. But the real success of these tools lay not in their code, but in their conceptual discipline. They discovered the one condition under which the ZUI truly works: when spatial organization is authored by the user, not imposed by the system. In tools like Figma, designers arrange interface screens spatially to mirror logical flows, navigation maps, or component hierarchies. In Miro, teams lay out mind maps, system diagrams, wireframes, or storyboards. These boards aren't arbitrary. They become cognitive landscapes themselves, structured collaboratively. Every group creates its own geography of thought. Landmarks emerge naturally, clusters of nodes, frames, or prototypes that orient the user. This self-authored structure solves the same orientation problem that defeated earlier ZUIs. The space no longer overwhelms because it is owned by the people using it. The canvas becomes a memory field, a map of collective reasoning. Parallel to this, another transformation was unfolding in how software itself was being designed. The logic of applications began to take on a spatial form. Modern programming and creative tools, such as Unreal Engine's Blueprint system, embrace this node-based visual programming, especially for complex stuff, like game programming or even advanced graphics. Functions and data flows are represented as interconnected nodes spread across an infinite canvas. In these environments, zooming isn't decoration. It is part of reasoning. You zoom out to see the overall system structure, then zoom in to adjust a single parameter or connection. Distance corresponds to abstraction, proximity to detail. The user literally moves through layers of logic. Scale becomes a language of comprehension. By early 2020s, this spatial grammar had become so natural that when generative AI entered the picture, the infinite canvas felt like its inevitable stage. Generative systems, text, image, audio, or even code, produce output that is nonlinear and expansive. They generate possibilities rather than answers, branching out rather than converging. ZUIs, with their fluid movement between scales, offer a perfect way to manage that abundance. Modern creative platforms like Kittle, Flora, or Recraft, and many others combine generative AI with canvas-based interaction. Designers can prompt hundreds of results, scatter them across the board, and then zoom out to assess compositions or zoom in to refine details. The interface supports exploration at both the micro and macro layers, something linear tools cannot provide. Meanwhile, frameworks like React Flow and Converge.js have made it trivial for developers to build zoomable node-based editors into these new AI products. This has led to a quiet standardization. The infinite canvas is no longer exotic. It is expected. Whether you're editing a workflow, mapping relationships, or prompting generative models, zoomable navigation has become the new normal. Some tools are pushing the concept even further. Web apps like Mosaic Video Editor merge the infinite canvas with video editing, replacing linear timelines with spatial layouts of scenes, effects, and generative clips. Creators move across space, assembling media like tiles in a mosaic. The same pattern now extends to AI orchestration systems, where complex chains of prompts, models, and actions must be visualized. The ZUI is perfectly suited to this because it externalizes causality. Each node or cluster becomes a viable part of the system's logic. The canvas becomes a living diagram of thought. This evolution points to a profound shift. Historically, humans became disoriented in infinite space because it lacked structure. But in AI-first systems, that structure no longer needs to be manually built. The machine itself can generate it. We can imagine an intelligent ZUI where the system automatically groups related elements, summarizes regions as you zoom out, and reveals detail as you zoom in. An adaptive landscape that mirrors human spatial memory rather than overwhelming it. In essence, AI can supply the scaffolding that earlier zoomable interfaces lacked: automatic categorization. Now, this is all in theory. When we open our laptops today, we still find ourselves facing the same desktop metaphor that has defined computing for 40+ years: windows, icons, menus, and pointers. The persistence of WIMP interfaces reveals the psychological and practical barriers that have always constrained the ZUI dream. I think there are 5 principal ones. First, it's about orientation and cognitive load. Infinite space overwhelms. Humans rely on boundaries the desktop provides them. Windows and folders act as perceptual anchors. Without them, attention becomes effortful. Second is performance and scalability. Even with modern hardware, maintaining smooth rendering across thousands of zoomable elements is complex. Scene management, level of detail rendering, and memory optimization remain non-trivial, especially if we added software to the mix. Right now, it's mostly images and text. Probably the most important one is convention and habit. Decades of software, infrastructure, and training reinforce the WIMP paradigm. It's good enough, and that inertia forms a barrier stronger than any technical limitation. One other thing is that general-purpose computing requires parallel tasks: editing, browsing, messaging, all visible and switchable. The window metaphor accommodates that naturally. A single canvas does not. Finally, there's semantic coherence. In a true infinite canvas, every object must remain meaningful at every scale. Maps can achieve this through semantic zoom, but for arbitrary content, documents, spreadsheets, media, or software, this becomes nearly impossible. For these reasons, the ZUI has remained a philosophy more than a platform. We see its gestures everywhere: pinch to zoom, spatial navigation, visual maps, but not its total realization. And even with that, some projects are still trying. One of them is tldraw.com, which is an infinite canvas originally, but their latest project, tldraw Computer, is an infinite canvas for natural language computing. It allows creation of workflows of connected components that generate and transform data using a multimodal language model as a runtime to execute instructions. It's doing a lot of things within the canvas. And what we see in operating systems today is small glimpses of system-level adoption. Apple Expose or Mission Control, for example, provide controlled zoom-outs that spatially arrange open windows. Trackpad gestures allow pinching and panning are becoming a standard, and they are micro-ZUIs embedded in a conventional system. But they operate at the surface, not the foundation. The infinite canvas then sits at this intersection of two opposing forces: absolute freedom and the human need for constraint. Too much freedom collapses into disorientation. Too much structure suffocates imagination. As AI systems generate vast interconnected worlds of data, new forms of organization will be required. If machines can learn to structure infinite space, in creating dynamic context instead of static scale, we may finally approach what early visionaries imagined: a living semantic landscape for human thought. The standard interaction model with AI today is still about chat.